Messed up on number 6 a little bit. X actually has 2 solutions, and the second one is 11.5, and that's because this function is actually equal to the absolute value of 4x plus 1, not just negative 4x plus 1. So that's why I got that one wrong. So there's 2 solutions for that. It's 11.5 and it's also negative 11. Okay, so for number 7 it says the output is going to be 2 minus x, and that's equal to this, which is negative 4x plus 1. So what I did for this was actually I subtracted 2 from both sides, so that gets rid of that. So negative x equals negative 4x plus 1 minus 2. And then I moved this whole thing over. So it's negative x minus the absolute value of negative 4x plus 1. That's equal to negative 2. And to solve this, I know that the absolute value can be either positive or negative. So what I did was, for one of them, I switched it. So for one of them, it was this equation. And for the other one, it was negative x minus, and then I flipped these, so it would be 4x minus 1 equals negative 2. And so for this one, I know I'm going to distribute both of those. So it's going to be 4x minus 1. That's positive. So that equals 3x minus 1 equals negative 2. Add 1 to both sides. So that equals 3x equals negative 1. Divided by 3, divided by 3. X equals negative 1/3. That's one of them. And then there's 2 solutions because it is an absolute value. Distribute, distribute. Negative 4x plus 1. Negative x minus that. So that'd be negative 5x plus 1 equals negative 2. Subtract 1 from both sides. Negative 5x equals negative 3. Divided by negative 5, divided by negative 5, x equals 3/5 is the second one. It's kind of confusing, but that was my best try at it. For number 8, I'm bringing it back to the Desmos graph. And so basically, x represents the number of t-shirts I sell, and y is going to represent the amount of money I make. So for the range, if I sell 0 t-shirts, I'd be at negative $1,000. And so basically, I can't sell negative t-shirts, so I can't go below $1,000. So range is the y. So basically, I can't go below $1,000, and I can make infinity amount of dollars. So the range should be written like this. So x is going to be the independent variable, where y is the dependent, because the amount of money I make depends on how many t-shirts I sell. So I can't sell negative t-shirts, like I said. So the least amount of money I can have at a time is negative $1,000, since that's what the y-intercept. And I can go to infinity amount of dollars. So that can be written also like this. That's an interval notation. And it can also be written like this. So x is between negative 1,000 and infinity, depending on how many t-shirts I sell. Alright, for number 9, it asks us, is the nonlinear function a combination of others? And that function is x minus 5x plus 1, all absolute valued. And yes, it is. It's the function of temperature 1 plus the function of temperature 2. Since that's equal to that, that's equal to that, and it's a minus sign because we are actually finding the difference, and that's also why it's an absolute value, is because the difference between, this is the temperature difference. The function of temperature difference can't be negative because it's a difference. This problem asks how we solved either question 3 or question 6. I'm going to do question 3 just because it's linear. So basically I figured out that I'm looking to find when I make back my $1,000. So I'm spending $20 each t-shirt I make. I'm making $20 each t-shirt I make, and I'm losing 12 because that's actual cost it costs to make the t-shirt. So basically, $1,000, subtract that, it's 8x. So I'm making $8 every t-shirt I sell. So here's always going to be $1,000 because that's my goal. $1,000. here is $20, and I'm losing 12 $1 bills. 6, 12. So I'm making $8. 1, 2, 3, 4, 5, 6, 7. Making $8 every t-shirt I sell. So basically it's asking how many t-shirts do I have to sell to make $1,000, and if each t-shirt's making me $8, dividing each side by 8, and it concludes that I need to sell, let's see if I can do this. I need to sell 125 t-shirts to make my $1,000.